Welcome everybody to my lecture on approximation algorithms. I'm Philipp Kindermann. I'm originally from Würzburg and I've also been working at University of Würzburg for the last 2.5 years as a postdoc. And now in summer semester, I have a replacement professorship here at University of Passau where I can give 2 lectures for you. This one that you're hearing right now, approximation algorithms, and also the second one on computational geometry. Unfortunately, because of the corona crisis, I cannot be there in person, and you will also not be there in person. So we cannot have an interaction as we usually do during the lecture. That means that everything has to work a bit differently. It's the first time for me I'm doing it like that, so maybe it will not be so great, but I'll try my best. So in the first video that you're watching now, I want to go through some organizational stuff. I want to tell you how the lecture will work this semester, and I want to tell you a little bit about some topics that we will talk about. The lectures will all be pre-recorded, as the one that you're watching right now. So every week, we usually have a lecture at Tuesday at 10, and during that time, I will upload a video and then you can watch the lecture on your own. Accompanying the lecture, there will be exercise sheets. It means we will have one exercise sheet per lecture, which I will also release on Tuesday around 10 a.m. There I will give you about 2 or 3 exercises, and then I give you 1 week time to also solve them. And then after that week, that means also on Tuesday, I will upload a video where I will give you the sketch of the solutions. I will not give you every single detail. But with the sketches that I present to you, you should be able to figure out the rest. And then, if you still have questions, we use the time slot of the tutorial, which is Thursday between 2 and 4 p.m. for a Zoom meeting. So we will have a 2-hour meeting there you can just join. You can ask me questions about the current tutorial sheet, about the previous week sheet, or about the lecture, and I can hopefully answer them. Of course, you can also ask me questions anytime. You can go to StudIP, you can write something in the forum there, or you can use the chat service there and ask questions, or you can just send me an email. And whatever it is, I will try to answer in time. Of course, there's no interaction now, and that means that I will condense everything a lot during the lectures. Usually a lecture is 90 minutes, but when I do the videos, it will be much shorter. Because in lectures, I often ask many questions. I give you a lot of time to think about solutions for yourself, and that's something that doesn't work well in the video. That means that from time to time, when I ask you a question, you will see a symbol like this one here, and then I urge you to pause the video, think about it for a few minutes, at least 2 or 3 minutes, and then you resume. Then you will see another symbol like this, and I will give you the answer. This does not work if you just keep the video running. So you should control the pace yourself. And that also speaks for the rest of the lecture. Oftentimes, many things will be a bit fast if you don't pause. So whenever there's something you don't immediately understand, pause, rewind, use those features. That helps you a lot. There are 2 textbooks that the lecture is mainly based on. In StudIP, I give you 5 textbooks, but really these 2 are the ones that you should look at. The first one is from Vasirani about approximation algorithms. This covers almost all the topics that we have here. And it's a very nice book, but he is also skipping many, many details. So it's a very high level overview, and things often seem to fall out of the sky for you if you're not familiar with it. So it's very great to get an overview, but if you need some more details, then maybe the second book helps you by Williamson and Schmois. They don't have all the topics we have here, but it's much more low level and much more detailed. So if you don't understand something in the lecture and not in the Vasirani book, then try to look at the second book. If that also doesn't help, then just ask me. I want to start off with a quote by the philosopher Bertrand Russell, who said, Although this may seem a paradox, all exact science is dominated by the idea of approximation. When a man tells you that he knows the exact truth about anything, you are safe in inferring that he is an inexact man. Every careful measurement in science is always given with a probable error. Every observer admits that he is likely wrong and knows about how much wrong he is likely to be. This is a philosophy that also applies to computer science. Many optimization problems that we want to solve are NP-hard. For example, the traveling salesman problem. The traveling salesman problem asks you, I have these 10 places that I want to visit. What is the shortest tour that I have to take such that I can visit them all? This is an NP-hard problem. That means that unless P equals NP, which many scientists think is not true, we cannot efficiently compute an optimal solution. And at least we have no idea how to find an optimal solution efficiently. But we can find good approximate solutions. And often we can find a solution where we can prove how good it is, how far away from the optimal solution it is, and we can find them efficiently. And that's what we want to do in this field of approximation algorithms. And that gives us techniques to design and analyze algorithms. And we get these techniques from studying specific optimization problems. So in this lecture, we will have a look at many of these problems, and for each of them, we will develop an approximation algorithm. And from that, you should get an overview of the most important designs, how to get a good approximation. I will now list a few algorithms that we will have a look at. We will start this lecture with the problem vertex cover, and then we will go on to set cover, and we will have a look at many other problems with combinatorial algorithms. Probably from the names, you will have no idea right now what these problems are, but at the end of the lecture, I hope that you can look again at this list and immediately tell me, how does this algorithm work? There are two types of algorithms. The first one are the combinatorial ones. That's what you usually do, and that's what you probably already know. But there's also a second type, which are LP-based algorithms. This is linear programming. So I will introduce to you what is a linear program and how can we use those to get good approximation algorithms. These are the two main parts of the lecture: combinatorial approximation algorithms and LP-based approximation algorithms.